All right, everybody, thanks for tuning in. All right, so today, me and Peter, we're gonna go over the meaning of centripetal force. All right, so centripetal force, when you break that down, you have cent, which is obviously meaning center, and then petal, which means seeking. So this would be also known as a center-seeking force.
As you can see, we've already gone ahead and drawn you the velocity vectors. Velocity vector meaning the direction in which you are traveling. So now that you're looking at this, you have to realize the path traveled by the object would be a circular one.
As Peter just said, we have to remember that in order for the object to move in a circular motion, another force has to be pulling the object towards an imaginative center. So this is our imaginative center. So I'm just go ahead and draw these forces that will be moving in. So this causes the object not to go in a straight line, because as Newton's first law of physics states, if there's no force acting on the body, then its velocity would not change. So in that case, it would just keep going on and on and on and on. But now that the force is acting and pulling it in, you get this circular motion that's revolving around the center. All right, now with that being said, you have to try and relate this to the real world. So say, for example, we took a ball. There's my best impression of a ball. And we attached a rope to that ball. And for some reason, we picked up this rope and started swinging the ball around and around and around. That ball, now bear with me here, would follow a circular motion. The reason for this is because the rope is pulling in on the ball. That ball wants to fly straight out, wants to go out, out, right? Because the momentum's carrying it. That rope, though, is pulling it inwards. So like we showed before, the same force is being applied here. Instead of going straight out, it's coming in and in and in and in again, so it goes around and around and around. Now, say for some reason we grew bored of whatever game we were playing right here and we let go, that ball would stop going around and would shoot straight out because this force here, which is pulling in on the ball, would no longer be applied.
The same principles can be applied to a satellite orbiting Earth. Let's say this red line is the satellite's orbit. The reason the satellite doesn't just continue off on its path the same way the ball and the string would is because gravity is acting in the same motion as the string and keeps the satellite pulled towards Earth.
Now, drifting is a little different from the other examples we've just shown you. For example, we'll bring this one back, the satellite orbiting Earth. The force acting upon the satellite is gravity. Now, don't get me wrong. Gravity is still acting upon the car, but it's not pulling the car towards this center here. It's actually just pushing it on the ground. No, what's forcing the car towards the center is its acceleration force, which is the force that your tires make when they be on the ground, which cause you to go forward. So you have your velocity vector, which is pushing the car forward for this first car here. It's pushing it forward, right? But then the car turns. So now your acceleration force is acting in a different direction. I'll start putting this here. And so your acceleration force, we'll do that in red. I'll get this next pen here. And this is your velocity vector. So now your acceleration force is starting to pull the car in. It's pulling in from your tires, right? So as the more you turn, right, the tires keep pulling you in, right? Instead of going straight, they're the force pulling you in. This is the satellite's gravity or the ball's strain. This is what's making you come towards the center.
Now that you understand how centripetal force works, we'll show you why we enjoy it so much. I'm sure everyone has gone and played around in the snow in their car and slid around in the parking lot. This is my favorite example of centripetal force and in my opinion the most fun. The tires help pull the car in a circular motion and prevent it from just continuing in a straight line.